Hello students, welcome to Into Maths classes. Today we are doing class 12 NCERT chapter 5, that is continuity and differentiability, and this is exercise 5.1 question number 18. Now for what value of lambda is the function defined as fx is equals to lambda into x square minus 2x when x is less than equals to 0 and 4x plus 1 when x is greater than 0. Continuous at x is equals to 0. So you have to find the value of lambda for which this function is continuous at x is equals to 0. Now, for continuity, consider your function first. Your function is fx is equals to lambda times x square minus 2x when x is less than equals to 0 and 4x plus 1 when x is greater than 0. Now, to check continuity at x is equals to 0, we are going to first calculate left hand limit, and that is equals to limiting value of your function as x tends to 0 minus, and to the left of 0 your function is defined as lambda x square minus 2x. So this will be equals to, by direct substitution we will get left hand limit is equals to 0, and for right hand limiting value of your fx as x tends to 0 plus, and to the right of 0 your function is defined as 4x plus 1, and by direct substitution we will get right hand limit as 0. Why? Since left hand limit is not equals to right hand limit, so your function fx is not continuous for any value of lambda. So there exists no value of lambda such that your function will become continuous at x is equals to 0. Now you are also find the value of lambda if fx is continuous at x is equals to 1. For x is equals to 1, your function at x is equals to 1, your left hand function definition and right hand function definition is same. So you are going to first calculate limiting value of your function as x tends to 1, and that will come from 4x plus 1, and by direct substitution we will get 5, and exact value of your function at x is equals to 1 will also come from this function, and that is also 5. Since limiting value of your function as x tends to 1 is equals to exact value of your function at 1, that implies your function fx is continuous for all values of lambda. So we can take any value of lambda and your function will become continuous at x is equals to 1. Your question 19 is, show that the function defined by gx is equals to x minus greatest integer function of x is discontinuous at all integral points. So let us consider your function that is x minus greatest integer function of x. Now you have to check continuity at integral points. So let c be an integer. Okay. Now if c is an integer, then there is a previous integer c minus 1 and next integer c plus 1, and we can define our greatest integer function in between c minus 1 to c. Your greatest integer function will be c minus 1, and from c to c plus 1, your greatest integer function will throw value c. Okay. Now, at this point, you have to check continuity of this function. So first, left hand limit, and left hand limit is limiting value of your function as x tends to c minus, and this is equals to limiting value of your function x minus greatest integer function of x. Now we are going to substitute x is equals to c minus h, where h tends to 0. So your limit will become limit h tends to 0. Your x will be replaced by c minus h minus greatest integer function of c minus h. And greatest integer function of c minus h, when to the left of c, your greatest integer function will throw c minus 1, c minus h minus c minus 1, and this will become limit h tends to 0, c will cancel out, and 1 minus h, and by direct substitution we will get 1. Now we are also going to calculate right hand limit, and right hand limit is limiting value of your function as x tends to c plus, and to the right of c, your function definition is x minus greatest integer function of x. Now if you put x is equals to c plus h, where h tends to 0, your limiting value will become limit h tends to 0, this is c plus h minus greatest integer function of c plus h, and to the right of c, your greatest integer function of will throw c only. So this will become c plus h minus c, and this will be c will cancel out and you will get right hand limit as 0. And since left hand limit is not equals to right hand limit, so limiting value of your function at integral point does not exist. And if limiting value does not exist, then your function is not continuous. And x is equals to c, or x is equals to c was arbitrary integer, so your fx is not continuous. At all integral points. Your question 20 is the function defined by fx is equals to x square minus sin x plus phi is continuous at x is equals to pi? Now, to check the continuity of this function at x is equals to pi, we are going to first consider this function. Your function fx is x square minus sin x plus phi. Okay, now consider x square. X square is a polynomial, and being a polynomial, it is continuous everywhere. Okay, sin x, second is sin x, and sin x is also a continuous function. For all x belongs to R, here also for all x belongs to R. And third one is phi, and being a constant function, it is also continuous. for all x belongs to R. Now, we know that the addition and subtraction of continuous functions is also a continuous function. That will implies that x square minus sin x plus 5 is also continuous for all x belongs to R, and this is your fx. So if fx is continuous for all x belongs to R, so fx is continuous at a particular point. X is equals to pi also. Now question number 21 is discuss the continuity of these functions, and your first function is sin x plus cos x, second function is sin x minus cos x, and the third function is sin x into cos x. We know that all the three functions are the composition, addition or subtraction or multiplication of two functions, sin x and cos x. So first of all, we are going to consider the continuity of sin x and cos x. Now we know that sin x is continuous for all x belongs to R. Also, cos x is continuous for all x belongs to R. So, the addition sin x plus cos x, subtraction sin x minus cos x, and multiplication sin x into cos x are also continuous for all x belongs to R. We know that the addition, subtraction, multiplication and quotient or the composition of two or three more continuous functions is also a continuous function. So we have applied this theory here. Now question number 22 is discuss the continuity of the cosine function, cosecant function, secant function and cotangent functions. Now first of all, let us consider your fx as cosine function. Now the domain of cosine function is the whole real line. So let us take an arbitrary real number, and at C we are going to check the continuity. So at x is equals to C, your limiting value, left hand limit is limit x tends to C minus fx, and that is limit x tends to C minus cos x. Now we are going to put x is equals to C minus h, where h tends to 0. So your limiting value will become limit h tends to 0, cos of x will be replaced by C minus h. Now cos of a minus b is cos a cos b plus sin a into sin b. Now direct substitution will give you h is equals to 0, cos h will become 1 and sin h will become 0. So this will give you cos c, and right hand limit will be limit x tends to c plus fx, and that is equals to limit x tends to c plus fx is cos x. Now put x is equals to c plus h, where h tends to 0. So your limit will become limit h tends to 0, cos of x will be replaced by c plus h, and this will give you cos a plus b will be cos a, cos b minus sin a, sin b. and by direct substitution h is equals to 0, this will become 0 and this will become 1 and it will give you cos c. And since left hand limit and right hand limit are equal, so limiting value of your function as x tends to c is cos c. Now exact value at c will also be cos c. Since limiting value of your function is equals to exact value of your function, so your fx is equals to cos c is continuous at x is equals to c. And since x is equals to c was an arbitrary real number, so your fx is a continuous function. Okay, and now we are going to discuss about cosecant. Now consider fx is equals to cosec x, and cosec x can be written as 1 upon sin x, which is the quotient function of two functions 1 and sin x, and 1 is a constant, and being a constant function it is continuous everywhere. Okay, and sin x is also continuous for all x belongs to R, but the rational function is continuous for all x belongs to R except where sin x is equals to 0. Sin x is equals to 0 कब होता है? When x is equals to n pi. So 1 upon sin cosec x is continuous for all x belongs to R minus आप कौन से पॉइंट्स करोगे? n pi, where n belongs to integers. These are the points where sin x is equals to 0. Now consider function secant. If you consider fx is equals to sec x, that can be written as 1 upon cos x, and again 1 being a constant function it is continuous everywhere, and cos x is also continuous everywhere. But 1 upon cos x will be continuous, is continuous for all x belongs to R except those points where cos x will become 0, and they are odd multiples of pi by 2. At all odd multiples of pi by 2, your cos x function will become 0. And your rational function is continuous for all x except these points. Now consider fx is equals to cotangent function cot x, and that is equals to cos x upon sin x. Again cos x is continuous everywhere, sin x is continuous everywhere. So cot x is continuous for all x belongs to R except those points where sin x denominator function will become 0, and that is all multiples of pi. Okay, so your cot x function is continuous when x belongs to R minus n pi and belongs to integers.